Hi, today we will be presenting project work for question number 1 for FAD1007 and its topic is about vitamin C. First of all, our group members is Wan Farid, Wan Izul, Nurin Adisa, Nurul Khadisa and I am Nur Kisina. First of all, introduction of vitamin C. It is a water-soluble vitamin and it dissolves in water and is given to the body's tissue, but it is not effectively stored. Therefore, it must be consumed daily through food or supplements. And it is also an effective antioxidant that may neutralize damaging free radicals and helps to manage infections and repair wounds. The vitamin assists in the production of numerous hormones and chemical messengers that are important in the brain and nerves. And vitamin C also helps the body's immune system by increasing the activity of white blood cells. Heat and light may both degrade vitamin C. Cooking at high temperature or for lengthy periods of time might degrade the vitamin because the vitamin is water soluble, so it can dissolve into cooking liquids and be lost if the liquids are not consumed.
Next, the stereoisomers of vitamin C. There are 4 stereoisomers of ascorbic acid, which is L-ascorbic acid, L-isoascorbic acid, D-ascorbic acid, and D-isoascorbic acid. So, for stereoisomer D-ascorbic acid and D-isoascorbic acid, they are called dextrorotatory compounds because they can rotate the plane polarized light clockwise, and they are denoted as plus sign or a small d in the IUPAC name. So, meanwhile, for stereoisomer L-ascorbic acid and L-isoascorbic acid, they are called levorotatory compounds because they can rotate the plane polarized light counterclockwise, and they are denoted as minus sign or a small l in the IUPAC name.
Next, I would like to explain about acidity of vitamin C. Vitamin C is also known as ascorbic acid. Ascorbic acid is considered as weak acid, which is HC6, H7, and O6. It dissociates partially in aqueous solution to form hydrogen ion or hydronium ions. The concentration of hydrogen or hydronium ions in solutions are always less than the concentration of the original acid, which is ascorbic acid. For example, an equilibrium established by ascorbic acid plus water will produce C6H7O6- plus hydronium ion. Ascorbic acid also has a relatively low Ka value, which is 8.0 times 10 to the power of -5, and a relatively high pKa value, which is 4.1. Both of these values indicate that ascorbic acid is a weak acid.
Okay, next we go to the formation of basic salt. Okay, first of all, we need to know what is the basic salt. Basic salt form when the strong base react with the weak acid, such as ascorbic acid. Basic salt contain the conjugate base of the weak acid, so when they dissolve in water, they react with water to yield a solution with pH greater than 7. So, what makes the basic salt basic? It is due to the fact that the anion in the salt is the conjugate base of the weak acid. Okay, we go through to the formation of basic salt using the ascorbic acid. It is formed when neutralization reaction of weak acid, which is ascorbic acid, with strong base, which is sodium hydroxide. The pH of aqueous solution of basic salt are more greater than 7. Okay, next is the formation. When the ascorbic acid reacts with the sodium hydroxide, it forms the sodium ascorbate and water. The neutralization reaction of ascorbic acid with the sodium hydroxide produces a basic salt, which is the sodium ascorbate, with a pH of 7.3 to 7.6. That is higher than 7, which is a basic pH. Okay, in aqueous solution, sodium ascorbate dissociate completely to form the sodium ion and ascorbate ion. The ascorbate ion of the basic salt will undergo the hydrolysis. The ascorbate ion will accept a proton from the water to form ascorbic acid and the hydroxide ion. Thus, we can conclude that the solution is basic.
Okay, next we move on to the solubility of effervescent vitamin C. Okay, first is the test of the solubility of the tablets in hot water. For the hot water, we use water with temperature between 70 to 90 degrees Celsius. The timer is started when the tablet is inserted into the hot water. While the timer is running, we observe the bubbles that are released. Okay, when the tablet is fully dissolved, the timer is stopped and the time taken is observed. Okay, as you can see in the video, in the hot water, the tablet dissolves within 1 minute and 30 seconds. That is quicker than in cold water. It should also have more vigorously produced bubbles than in the cold water. Okay, for the theory, the hot water has more energy than cold water. The tablet molecules gain more energy and collide with the water molecules faster, causing it to be more soluble in hot water. The tablets contain sodium bicarbonate, which reacts with the hot water that is high in energy, causing it to produce more carbon dioxide, that is the bubbles produced. Okay, let's move on to the test of solubility of the tablets in cold water. For the cold water, we use water with temperature between 10 to 20 degrees Celsius. Okay, the timer is started when the tablet is inserted into the cold water. While the timer is running, we observe the bubbles that are released. When the tablet is fully dissolved, the timer is stopped and the time taken is observed. Okay, as you can see in the video, when the tablet is added to the cold water, it took within 2 minutes and 32 seconds to dissolve, which is much longer than in hot water. The bubbles produced are less vigorous compared to the tablets in the hot water. Okay, for the theory, the cold water has less energy than the hot water. The tablet molecules gain less energy and collide with the water molecules slower, causing it to be less soluble in cold water. The sodium bicarbonate in the tablet reacts with the cold water that is low in energy, causing it to produce less carbon dioxide, that is the bubbles we see in the video. We move on to the equation. When ascorbic acid and sodium bicarbonate get together in water, sodium ascorbate water and carbon dioxide gas is produced. When carbon dioxide gas is released, it causes the fizziness of the bubbles, as we can see in the previous videos.